All right, what's up, guys? In this video, I'm going to pick up some calculus here, and we're going to do another trig integral, some trigonometric integration. So we're going to evaluate the integral sine squared of pi x multiplied by cosine to the fifth of pi x dx, and this is example number 4. All right, let's get started with it. So clearly, we start with a u, okay? So u is pi times x, or pi x. We take the derivative of that. If we take the derivative of that, that's just pi multiplied by dx. And then we get 1 over pi du is equal to dx. A lot of people forget that pi is just a number. Remember, pi is 3.14. I don't even know what the rest of the numbers that come after. I don't even know what they are, but it doesn't matter because it's just a constant, and the derivative of any constant is 0. So keep that in mind about pi. A lot of people forget about pi. All right, so looks like we got 1 over pi multiplied, and looks like we'll have sine squared of u multiplied by cosine to the fifth of u du. So we've done ones similar to this before. You just got to break up the trig function or trig expression that you're given in some cases and try to make it so that you can apply a particular integration technique to it. Since we have a cosine to the fifth, that's the one that we want to rewrite. So remember that cosine to the fifth of u, that's the same thing as cosine to the fourth of u multiplied by cosine of u, because although it's not explicitly written, that cosine is being raised to the first power. We add the powers, we get 5. And we also know that cosine to the fourth of u can be rewritten as cosine squared of u all squared. And we know that cosine squared of u, that's just 1 minus sine squared of u, because remember that sine squared theta plus cosine squared theta is equal to 1. So therefore, we can say that 1 minus sine squared of u squared is what we can simplify that to. And so now we just go back to our integral. So we got 1 over pi, and then it's just the integral, and we just leave the sine squared of u alone. We didn't touch that. Then we got 1 minus sine squared of u. Don't forget that's squared as well. And remember, we have our leftover cosine, and this is all integrated with respect to u. Now, when you look at this in contrast to what we had up there, it may look like we made the integral worse, but we really didn't, because when we started here, there was no particular integration technique that we can start with. So although this looks like we made it worse, it's actually not, because now we can do another substitution. And if you have to do another substitution, as I talked about in previous videos, you want to use a different variable. It doesn't matter which one you use. Most people use v. I like to go on a little unconventional and just use w. It doesn't matter what variable you choose to do the second substitution with, but just don't use the first variable that you used. So let's do another substitution, and I'm going to pick w to be sine of u, because the derivative of that is in the integrand. So dw is cosine of u du, and then we du, not dw by the way, and then we got 1 over cosine of u dw is equal to du when we solve for that. Okay, and what that does is it cancels out the cosine. Okay, and then this becomes w squared. This becomes 1 minus w squared, quantity squared. So the 1 over pi, we didn't do anything with that. Remember, that was still out there. And then we got w squared, and we got 1 minus w squared, quantity squared, dw. The best thing to do here is to expand things out. So we get 1 minus w squared, quantity squared, That's just 1 minus w times 1 minus w. So I can do this in my head. That's going to be 1 minus 2w squared plus w to the 4th power. We'll then take the w squared and distribute it in for this. W, by the way, sorry. And we'll go back to our integral. So we'll have 1 over pi times the integral. And if we distribute that w squared in, so it looks like we'll get the integral w squared dw minus the integral 2w to the 4th dw. Then we'll have plus the integral. It looks like we'll have w to the 6th dw. And this is where we're at. So this is w cubed over 3. This is 2 times w to the 5th over 5. And then this is w to the 7th all over 7. So we're pretty much almost done. Let's continue, get another sheet. Okay, so let's acknowledge the substitutions that we had earlier. U was pi x, or pi times x. And w was sine of u. So what we got is 1 over pi. So we'll have sine cubed pi times x all over 3 minus 2 sine to the 5th of pi times x all over 5. And this will be plus sine to the 7th of pi times x all over 7. And we'll need to simplify it a little bit and write our final answer. So our final answer for this one it was the integral sine squared of pi x, or pi times x, multiplied by cosine to the 5th of pi times x, and that was integral respect to x. So our answer here, I'm going to write it as 1 over 3 pi sine cubed of pi times x minus 2 over 5 pi sine to the 5th of pi times x, and this would be 1 over 7 pi sine to the 7th of pi times x, and then we need a integration constant plus c. So that's the long answer, but it is the answer. All right, so hopefully that one wasn't too much of a hassle, and hopefully you were able to follow me on that one. All right, so let me know if you got any questions about it. We'll see you next time.